Welcome to more of Doe's Fun with Tech Phones. This episode is so you bought some DNVTs on eBay. I've been noticing you can buy a lot of DNVTs on eBay lately. Started making me think which one of these are actually operable with each other. So what we did is we went out and did some testing between the different DNVTs to see which ones were operable with each other. So go ahead and watch the video. I hope you learned something, and if you have any questions, please comment at the end. And here we go. Episode 2. So you bought some DNVTs on eBay. Okay, this is a DNVT TA954. The coolest thing about this phone is it comes in this nice carrying case. That's about it. The phone itself, we'll get it out, is a TA954. It was developed as part of the DoD's TriTac program, which basically was to develop interoperability between the different branches and everything from satellites to telephones to radios, on and on and on. But this is one of the results, is the TA954. It's basically a digital, non-secure voice terminal. Got that nice deal to hold the handset on there. They basically all the DNVTs, or some of them, have the same thing in common. They're all based on a ruggedized case like this that is weatherproof. It's got a volume control right here to control the volume of the handset, and also you can control the volume of the ringer anywhere from low to off. It's got a ring indicator that actually will give you a light that will flash when it comes on. It's got the standard military dial keypad. It's got all the precedence buttons on it, and the ring buttons like that. It's a 4-wire digital phone. Here's the binding post for it right here. It functions as uses what's called conditioned diphase, or otherwise known as Manchester signaling. This unit actually is a common battery system. It pulls power from the switch itself, which means that it can't be used in a point-to-point application. It's got a selector here on the side. It's upside down for you guys. You can either select 16 or 32 kilobits, the operating speed for it. There's a checkbox there, spot for you to write on with phone number. And that's pretty much it. It uses a H350 handset. Looks identical to an H250, but it's got 6 pins on it, and it's wired differently. I've seen many of that exercise come to a screeching halt because somebody didn't have the right handsets on radios or telephones and they wouldn't work. If you were to connect this onto a radio, you could hear okay through the speaker, but you couldn't talk. The same if you put an H250 radio handset on this, you could hear but you couldn't talk. So that was a major problem. These are also set up so that you don't have to PTT to talk. When you pick the phone up and answer it, it's live to talk. And that's one of the reasons that they use an H350 instead of a 250. It is possible to go into the unit level switch that this is actually connected to and set it up to operate as either a full or half duplex. And half duplex operations, you can actually key it up to talk and release like you would on a normal 2-wire system. This will not interface with your phone lines at home. It will not interface with the field phones that we looked at. It's a purely digital system that's got to operate with digital equipment, whether that's a TEC39, which is a large unit level switchboard, or a TEC42, which is a unit level, or SV3865, or Army MSE equipment. It will not, just plug in and operate. I will give a shout out to A1 Telephone Electronics. They will actually take one of these and gut it and put new guts in it so you can use it on your phone lines at home. I guess this is a big Battlestar Galactica fan deal. I guess they use these in Battlestar Galactica. Anyway, that's it. This is a TA954. Okay, this is another version of the DNVT. This is a TA1042. Looks a little bit different. Same ideas as the DNVT as the 954 was. Ruggedized plastic case. It's got volume control for the ring and that. The selector in this one's on the front, but it does have the ability to either run the phone in common battery or local battery operation. In local battery operation, you would hook a battery to your power source right here. I've used anything from 6-volt batteries to wall wart transformers that are anywhere between 9 and about 20-some volts. It usually works the best. And we usually run that in point-to-point mode. It's got the keypad on it like the other one. This was a little bit different because it's got a digital data port on it. That's this connector right here. And what this allowed it to do was connect to an external data device, usually a teletype. I know a UGC 144 teletype would connect to it, or a UXC7 tactical digital fax could connect to it. I also know the Army had a thing called an MSE box, and what it allowed you to do was connect it to the port right there. It had a small box about the size of, I suppose, a pack of cigarettes, and it had a connector on it. You could actually plug that into a laptop computer, and then using Hyperterminal, you could make a phone call to another person on this, have them plug, and you could transfer data over it. It was only at rates of 4.8 or so, but I mean, back in the 90s, that was cool to be able to send files back and forth. It operates well. It's rugged. Like I said, what's nice about this is the ability to operate it in local battery mode, and when it's in local battery mode, it will actually function as a point-to-point phone. So if you were to take another 1042, put it out here, and we wired them together and put battery on both of them, you could actually make calls back and forth. And that's a 1042. Okay, this is a interface unit automatic data processing, CA67/U. It was developed by the Army as part of their MSC program, their mobile subscriber equipment. And it's basically a modem. You can set it up to do different things that allow them to connect computers up in the field and send stuff back and forth through their tactical switching system using the MSE. I'm interested in it because it has a function where it'll function as an actual DNVT. And it's pretty much just a ruggedized case like the other ones. It's interesting because it's got this plug on it to plug it in, or to use, you can just plug it into a normal AC outlet. In addition to that, it actually has binding posts here for power. These binding posts are where your field wire will connect. It's got a data port, like a 1042 does. It's got an actual 232 port where you could actually plug a computer in here. And then it's got a DNVT port where we could actually connect it up to, or excuse me, a DSVT port, we could actually connect it up to a DSVT. Like I said, I was interested in this unit because you can set it up and you could run it as a actual DNVT and make phone calls. It's got this switch right here. You can set your data rate right here. I have it set to point-to-point, so when it's time to do our testing, we'll go ahead, we'll plug it up, and we'll test it in a point-to-point mode. And like I said, this is a CA67/U. Okay, now we'll do some TA1042 DNVT checks in a point-to-point configuration. So here we go. Test, 1, 2. Test, 1, 2. Okay, that was loud and clear. Okay, we'll go ahead and go the other way. Test, 1, 2. Test, 1, 2, 3. Those tests were done in 16 kilobits local battery. This DNVT I actually have powered with external power using a battery. This one right here I'm actually using a plug-in 9-volt wall transformer. We worked with that before, and that seems to work pretty good. Anywhere the voltage between 9 and 20-some volts, and it works. And that was TA1042 DNVT point-to-point checks. CA67 point-to-point checks. As you can see, I have them both plugged into using our AC power cords. They're both sent to point-to-point. Using some Cat5 between them, we'll go ahead and make a call. They're set in point-to-point. Test 1, 2. Test 1, 2, 3. Okay, that worked both ways. I noticed there's a little bit of a delay in the ring from the time I picked the phone up to the other side ring. Okay, now we'll ring from this one to this one. Okay, we're off hook. Seeing a ring indication. Now there's the actual ring coming through. Test 1, 2. Test 1, 2, 3. Test, test, test. Test 1, 2, 3. And that's that. That's a CA67 check. This is something interesting I learned on the TA954. If you apply power to the terminal, the binding post, like you would like you'd be getting power from the switch, you can actually power the phone. So you can see the light comes on. Test 1, 2. I actually have a little bit of tone in it and some dial tone. The buttons don't work, but it does have audio, so that's interesting that you can power it by applying power to the binding post. Remember that for our next test. Okay, now for our final test, we're going to do some compatibility checks between these different DNVTs. We know that some of them will operate in a point-to-point mode between each other, and the question now is which units will talk to which other units. So the first thing we'll do is we'll check the CA67 and the TA1042. And here we go. That's a good sign. Test 1, 2. Test 1, 2, 3. Test 1, 2. That's interesting. Both of them have side tone. You can hear you talking on the handset here. But for some reason, it'll only transmit this way. So when I talk on this one, I can hear it on this one. Test 1, 2. Okay. Let's go ahead and hang everything up. Now let's try and go from the 1042 to the CA67 and see what we get. It's interesting, I'm not even showing a ring being sent. Test 1, 2. Test 1, 2. Same deal, that's interesting. You can only talk between this one and this one, but it'll ring the other way. So that's interesting. So evidently there's something within the data programming on these that will not allow them to operate in a point-to-point mode with each other. Now, if you connected these up to an actual switch themselves and actually made dial phone calls between them, they'd operate. I find that interesting. Okay, for this round of testing, we're actually going to go between the TA1042 and the TA954. So here we go. We'll call from this way first. Rings. Test 1, 2, 3. Test 1, 2, 3. Interesting. I could talk this way and I could hear on this one, but I couldn't talk the other way. So it's similar to the last check we did. The TA1042 can always talk. Now we'll go the other way and call from the 954 to the 1042. That's not going to work. It's evident that something in the internal programming on the PROM chips themselves determine whether this can call out. We know this will work with a switchboard, but it won't work in point-to-point mode. So that's very interesting. But it is interesting to note that you can call one way and at least talk to somebody. They can't talk back to you, but you can tell somebody something. So that is a TA1042 to a TA954 check. Okay, this is our final check. We're going to actually check between the CA67 and the TA954. When in point-to-point mode, this one is 16 kilobits, so I have this one set for 16 kilobits, and we'll start by calling from this phone to this phone to see what happens. Well, it's trying to. You can actually hear trying to sync up inside the handset. We get an occasional, there we go, ring. It's just not quite syncing up. And that's because I think, like I said before, the 954 lacks the firmware inside to allow it point-to-point operation, so it doesn't quite know what to do. Well, test 1, 2, 3, test. Test 1, 2. Test 1, 2. It's not going to sync up. That's interesting. So we now know that the DNVTs basically have to talk to with a DNVT within their same class or model number. We know that this will talk to another CA67, and the 1042 will talk to another 1042, and basically for point-to-point operations, the 954 is nothing but a giant paperweight since it lacks the firmware to do point-to-point operations. Thanks for watching this episode about DNVTs. We had some interesting results, and I hope everybody learned something. If you have any questions or comments, please respond.